All right, and here is the lesson 2.2 characteristics of quadratic function notes. Kind of a big lesson, and know that in class we split this into 2 days, so I'll make sure I mention at that spot. So in case you missed a single day or the first day or the second day, you can kind of jump to that spot. But for right now, I'm planning on just going through the whole thing, so it'll end up being a longer video. Don't let that scare you away. Obviously, you can jump around as needed. So let's get into it. Obviously, the main idea is graphing, all right, and treating and looking at some of these key features of graphs, the vertex. Well, we'll get into that in a second, but then ultimately tying it to some real life, some word problems. Okay, so I'm going to try to make it manageable, but I know it's going to end up being a longer video. But here we go. All right, so key properties that every parabola has is a vertex, axis of symmetry. It's going to either open up or down. It's going to have a y-intercept or a maximum or minimum value. So I think even right here, just in class, we'd go through, I don't know if we necessarily need an x and y axis, but whatever. We'll put a parabola. That's our shape. We've talked about it in previous lessons. Our vertex, every parabola has a vertex. All right. Every parabola is going to have right here, I'm kind of jumping around a little bit, but it's right next to my vertex. That's our y-intercept. The axis of symmetry. So we've checked out, hey, we've talked about the vertex, the y-intercept. The axis of symmetry is the vertical line that passes through the vertex. It basically cuts our parabola in half, passes right through the middle, is going to be of the form x equals, whatever that is. In us, it kind of looks like that would be a -1 here. We're just one x unit, or 1 unit to the left on the x-axis, right? Left 1. So something like that, x equals -1 would be an example of a axis of symmetry. Every one is going to either open up or down. We could potentially have a graph that does this with all the same features, vertex, the y-axis, axis of symmetry, and then connected right with our vertex is the maximum or minimum value. So we've got both figures here. I guess we might as well talk about them. Every graph that opens down, so these are totally connected. If a graph opens down right here, this would be a max value. That's an automatic. That's a black and white. Every graph that opens down has a maximum value, where every graph that opens up has a minimum value. There's a bottom. There's a basement to that graph. And for us, the minimum value is going to end up being the y-coordinate of the vertex. So the vertex is kind of the big deal as far as it tells us a lot of stuff. All right, well, obviously it's the vertex, but it's totally connected to the axis of symmetry. This axis of symmetry is also always the x coordinate of vertex. That's not very good. Let's clean that up. Let's not rush. Do it right. The x coordinate of vertex. So there's 3 different pieces here: the vertex, axis of symmetry, and the maximum minimum value that are all connected to the vertex. All right, so this is just a generic notes of parabolas, some stuff that will apply to the different forms. Our job today is basically to get through 3 different forms that we'll see quadratic functions or parabolas written as. Okay, so the first one here is vertex form. Briefly mentioned in 2.1, actually only specifically mentioned in 2.1, but it was covered a little bit. Go back and check out the 2.1 notes if you're kind of wondering where this is coming from. Y equals a times the quantity x minus h squared plus k. All right, that's the generic form. The vertex, let's go through. Let's kind of treat this like, we'll try to do it the same for everyone if I can remember my order here. I'm going to use AOS for abbreviation for axis of symmetry. We'll have, let's do opens, either up or down. Let's do y-intercept. And then let's do max / min value. And I'll try to do this for all 3 forms to keep it consistent. When it comes to graphing purposes, this is the absolute form that we want to see. It's the easiest because we can look at this and see, hey, I know my vertex is the numbers that are right here, this H and this K. So when we start filling things in, this is where we would start. We would start with our vertex. I can look at anything in vertex form and say, hey, this has the coordinate, the vertex has the coordinates HK, whatever those numbers happen to be. Right along with that, if I know, we said on the previous slide that this x coordinate of the vertex is also the axis of symmetry, that's another freebie, I'll call it. Free piece of information. The vertical line x equals whatever number this is, the x coordinate of the vertex. Let's jump ahead here a little bit. What did we say the maximum or minimum value is going to be? It's always going to be equal to the y value of the vertex. So it's y equals k, whatever that number is. These are all just free things I essentially get by understanding the form and how it works. A is going to tell us whether the graph opens up or down, the sign of it. So basically, if A is, let's just say this is positive, you could say greater than 0. If A is positive, it's going to open up. If A is negative, we'll just say opens down. And that should be hopefully not out of left field, because we talked about a negative A value reflecting a graph over the x-axis would turn it upside down. And then based on that, we said an automatic black and white is if it opens up, it's going to have a minimum value. If it opens down, it's going to have a maximum value. So I'll just ask you to circle one of those depending on whether it's opening up or down. The last part, so all that stuff was kind of just free. I just looked at this. I saw, okay, A was positive, it was negative. I knew the vertex. I know the axis of symmetry, the y, or the maximum minimum value. The only thing that we actually have to kind of calculate, I'll change color on it, is going to be the y-intercept. Plug in 0 for x, solve for y. All right. In other words, and this is true for every y-intercept, whether it's a parabola or or any other type of graph, it's going to have the same thing's always going to be true. The x value is going to be 0. It's going to be 0 something, 0, 5, 0, 10, 0, negative 11, whatever it happens to be. So that's kind of, for this form, that's really the only plug-in that we have to do to get going. All right, so we'll run through a couple quick practices here. Here just says I can graph functions in vertex form. So I can see this. Obviously, we filled in some numbers for our h's and k's. Maybe I'll try to color code it and stay the same with all my freebie stuff. So I see this. The first thing I know the order here is a little different with AOS, vertex, whatever. I look at this and see that my vertex is -1. Let's go with red. -1, -2. Be careful there. Remember, the form is written x minus h. So this must have been -1, x minus -1, in order for this to turn into plus here. So x minus -1, that's why my x value of my vertex is always opposite of what it kind of looks like in there. All right, so it looks like +1. My actual vertex is -1. Let's finish all this other stuff. The axis of symmetry is the vertical line x equals -1 based on this -1 right here. I can look at my A value, right? A value is right here, 1/2. It's positive, so that means my graph is going to open up. It's going to take on this kind of generic shape, which every shape that looks like that has a bottom basement to it, a minimum value, so just circle minimum. What is the value of that minimum? It is the y coordinate of the vertex, so y equals -2. So right off the bat, I got a ton of stuff filled in here. How I like to make the graphs is I like to stick this vertex right in the middle of my table, -1, -2. I can put some of that stuff on the graph. Let's put all that on there. I know my axis of symmetry is a vertical line passing through x equals -1. Let's see, maybe we'll change color here just to make it stand out. My -1, -2 is my vertex. We know it's going to open up. From here, the last part is plugging in some values. I usually save the y-intercept for the end anyways, because I think we can kind of double up as far as kill two birds with one stone. Is like, what are the x values that we're going to plug in here? All right, so from -1 going up, we'd go up 1, up to 0, then up to 1 or 2. That's fine. We could even go up to, you could plug in as many points as you want. Going the other way, we'd go to -2, -3, down to -4 if we wanted to. Doesn't really matter as far as how many, but we've got it centered there. That's the whole idea of putting our vertex in the middle, and then we'll kind of get a 2-for-1 deal here. So if I plug in a 0, that's what I mean. Like we can double dip here. I know my y-intercept is going to be 0 something. It's also going to be a good spot to get a point on the graph. So the last thing we got to do is just plug these numbers in and crunch the numbers. So I'm going to talk through it. I would encourage you to show your work and not do so much on the calculator. The big issue that I see with students a lot of times is they lean maybe too much on the calculator, where I can potentially get by some of this stuff without actually using my calculator. So if I plug in a 0 right here for x, all right, 0's going in right here. What do I have to do first? I have to add 1. So 0 plus 1 is 1. The next thing that has to happen is I have to square it. I'm just following my old school order of operations. So 0 plus 1 is 1. 1 squared is 1. 1 times 1/2 is 1/2. And then 1 half minus 2 is -1.5. Let's change color here. -1.5. And the nice part about this being a symmetric graph, it's the same on both sides. So 0, -1.5, that has to be true over here as well. So as long as I'm moving equal distance from the vertex, right, I went 1, left, I go 1, those same points should be there. And I don't have to plug in -2 to get that. All right. Like we said 3 or 4 times, hey, we doubled up there. I might as well just fill this in right away for my y-intercept of being negative. That's a -1.5. All right, let's go through. Let's get these last numbers plugged in. Plug in a 1 here. 1 plus 1 is 2. 2 squared is 4. 4 times 1/2 is 2. 2 minus 2 is 0. All right, so I ended up with 1, 0, and -3, 0. So let's plot them right away. 1, 0, and -3, 0. This, if I was plugging in a third set of points, I probably wouldn't go with 2. I'd actually jump to 3 and -5. Why? Let me see why. Because the first thing we do is add 1 to it. So 3 plus 1 is 4. 4 squared is 16. I just like cutting it in half and getting a nice number. So like I said, 3 plus 1 is 4. 4 squared is 16. 16 times 1/2 is 8. 8 minus 2 is 6. I'm not saying you have to plug in that extra set of points, but I can kind of see what's going on here. I'm going to have the room for it. 1, 2, 3, 4, 5, 6. I think I counted that right. And then I'm just going to count over the axis of symmetry. 1, 2, 3, 4. 1, 2, 3, 4 to get my last set of points there. So other than us just connecting our points here with a nice, beautiful brown colored pen, that's it. So double check that everything got filled in. All right. Yep. Minimum value. We did it. That's it. There's no comparisons to the parent function. There's no, it's really just kind of the mechanical process of graphing in this form. All right. Let's do one more. Again, it's a video note, so I understand that you can skip this if you want. We'll just kind of go through it quick here. All right. So same process. Vertex. I look at this. I see vertex 3, 0. I'm sorry, 3, 4. Let's not go so fast that I screw up. So I do have to kind of make sure we're doing this right. So the point 3, 4 is my vertex. We can put it on the graph right away. 1, 2, 3. 1, 2, 3, 4. My axis of symmetry is x equals 3. So it's going to be the vertical line that passes right through this point here. We'll just use a dashed line on your graph. You don't have to label it because we got it labeled right here. Let's see, it's going to open down this time. Why? Because of that negative a value. So -1. Because it's opening down, every downwards opening parabola has a maximum value. And that maximum value is the y-coordinate of the vertex. So y equals 4. That'll be the tip top of this graph. It's going to go down from there. Just like before, I'll put this vertex in the middle of my table. Let's see here. If I branch out from there, if I'm truly just branching out by 1s, we would go up to 4 and 5 and then down to 2 and 1. So you can kind of see on this one, I do have the dilemma. At some point, I'm going to have to plug in a 0 anyways to get my y-intercept. So you might be strategic with how you do it and say, you know what, and instead of jumping down, I can maybe go down from 3 to 2, but then from 2 to 0 and do that kind of double up process, I'm totally fine with that. All right, so at some point, I'm going to end up with this other set, which is fine. So here we go. The last thing to do is kind of plug these numbers in. 4 goes in here. Follow your order of operations. 4 minus 3. I like to plug in just the bigger numbers first, or go up from here and keep my numbers positive. So 4 minus 3 is 1. 1 squared is 1. I have to multiply by -1, so now it's -1. And then -1 plus 4 is 3. So you follow me there on that? This negative, I can't ignore it out here, and it comes third in the things that I do. 4 minus 3, done. Square it, done. Now times -1, and then back to plus 4. All right, so let's do one more round with the 5. I guess we'll have to do it with the 5 and the 6. So 5 minus 3 is 2. 2 squared is 4. 4 times -1 is -4. -4 plus 4 is 0. So the numbers are doing what I would hope they would do too. So if I start plotting these, maybe we should take a look at them. 1, 2, 3, 4, 1, 2, 3. And then I got one here. This graph is opening down. If something was going on, I started getting points like up here and here, I know I'm making a mistake because this graph should be opening down from the vertex. So there's some built-in stuff there as far as checking it out. Let's put this next one on there. 1, 2, 3, 4, 5, 0, and 1, 0. Now, I could absolutely be done making the graph, and I don't know if my next set of points is going to fit. It looks like that y-intercept is going to be somewhere down here. So it may not even fit on the graph. So this is one that I might just have to calculate. It's not going to fit. I'm just going to fill in this last point, though. All right, so just personally, I'd probably like to plug in the 6. Not that it's a big deal, but 6 minus 3 is 3. 3 squared is 9. Make it negative, or the opposite of 9 is -9. Plus 4 is -5. So it did go off the graph a little bit, and there's nothing wrong with that. If there was room, I would try to plot it, but there isn't, so it's fine. So 0, -5 ends up being our y-intercept. And I think we hit everything. X of symmetry, vertex, y-intercept, open down, nice table of values. Yeah, I think we're in good shape. Get this out of here. This bugs me. I don't know. It's all right. So there's vertex form. We'll revisit that when we get to some of the word problems, but that's the process. All right. Next form. So it's basically start over now. Hey, vertex. How do we find the vertex? X of symmetry opens up, y-intercept, maximum, minimum value, but in a different form. We saw that one. Hopefully, after we maybe see these other tools, say, wow, yeah, that first one was pretty convenient. Next one is called standard form. So let's start with the generic. This might be the one that you're most familiar with. In a previous algebra class, you probably used the quadratic formula a lot. You probably saw a lot of quadratic just functions in this form. Y equals ax squared plus bx plus c. And again, a, b, and c are going to all be number values. So we'll see with numbers. Let's see if I can do this right. Vertex, x of symmetry. So I want to keep in that same order. Vertex, axis of symmetry. I already forgot. What did we do next? Opens. I think so. Opens. Y-intercept. And then max min value. So I got to start in a different spot here because I'm not able to just look at this and see like, oh, hey, that's my vertex. It doesn't work that way in standard form. These numbers do mean things, but for graphing purposes, it's not that great. There's a couple little freebies here. So if I start with the free stuff, we can still tell whether it opens up or down. That's based on A. That part has not changed. Basically the same rule. If A is positive, we're going to say it's going to open up. If A is negative, it's going to open down. So the same exact rule, I could answer that question. And because of that same rule, I would know if there's a maximum or minimum. I would circle that. I don't know the value of it yet, though. Different from the last form, it's almost the exact opposite, where we don't know the vertex, don't know the axis of symmetry, don't know the maximum minimum value. The only thing we actually know for sure is that the y-intercept is 0, c. So we get the y-intercept for free. And where that comes from is obviously if we plug in a 0 here and here, these terms would essentially just go away. 0 times b is 0. 0 squared times a is 0. But the c would never actually go away. So 0c is our y-intercept. All right, so now we do have a little bit of work cut out for us. It's not terrible, but we would start with, this is where we would kind of start doing some work, is the axis of symmetry. So we would start with this equation, x equals the opposite of b over 2 times a. So that's something we're going to have to know, have to be able to do, and understand, like, that's where I'm going to start with my a standard form graph or a standard form word problem. From there, once I crunch that number, whatever it comes out to be, that value, I know it's going to be kind of tight on space here, actually ends up being, just like before, the x-coordinate of your vertex. So it's kind of that double up. All right, I had to do some work for the axis of symmetry, but that number that this works out to, whatever it works out to, is also the x-coordinate of the vertex. How do we find the y-coordinate of the vertex? I got to crunch more numbers. I got to take this AOS value and plug it into the function. So let's just say it like this. I'm trying to make it like manageable for us. The plug, let's just do this. Let's keep it simple. Plug AOS value, whoops, I meant to write a V. Plug AOS value into function, and then evaluate, like simplify to get just down to a single number. All right, we'll do that. Hopefully that'll clarify that, but that's how we're going to get our vertex. From there, now we know that it's the same as before, that the maximum minimum value is going to end up being the y coordinate of vertex. Let's just say that, so we don't have to write that big, the same thing again. But once I know that vertex, all right, the door's open now. All right, I know the maximum minimum value. We can graph it. We can center our table up. So there's a little bit of a process there. The couple freebies in blue, where do we start then? Start with the axis of symmetry, opposite of b over 2a. All right, so same deal. We'll run through. I know we're kind of getting a little bit longer already. Let's do these next two graphs in class. That's where we would have broke our notes. We'd finish examples 2 and then on your own 2, and we would have broke after day 1. So let's get through these ones. Graphing and graphing a function in standard form. So I'll do the same thing. Let's do blue for the freebies. I look at this and see a positive a value of 3. So I know that this graph is going to open up and have that kind of generic shape. So I know that this graph is going to have a minimum value. The other one nice freebie point that I end up getting is this c value, 0, 1 would be our y-intercept. So we could put it on the graph. Why not? 0, 1. The problem is I don't know who its partner is. Remember, these points all have a partner, like we did here. This one's partner was over here. This one's partner was over here. Other than the vertex. The vertex stands alone. But I don't know, like, I need to know the axis of symmetry to figure out like where this one's partner is. So, all right, let's do it. Let's get into it. I'm going to kind of maybe do my work here on the bottom just so we can see. So to start with the axis of symmetry, we said that's kind of where the work has to start. I'm going to use the opposite of b. So right now b is -6. So the opposite of b is +6 over 2 times a, which is 3. So 6 over 6, which is 1. So x equals 1 for the axis of symmetry. Let's go ahead and put that dashed line on the graph. X equals 1. Let's see. That gets me rolling a little bit. I know half my vertex is 1 something. I can kind of center up my table here if I want. 1 something. Okay. So that to figure out that something now, we said the note was plug this value into the function and simplify. So let's do that. I need to plug in a 1. Let's see, I'll kind of talk through it here. I would still probably write some of this down. So if I know you can't see me, but I haven't touched my calculator for a lot of these, and most of the operations are like doable without a calculator. So that's where I see sometimes students get so wrapped up in their calculator that they kind of miss the order of how things are going, or they trust the calculator too much. So Anyways, so I'm plugging in a 1 value for both this x and this x. So let's do kind of just this term first. If I plug in a 1 here, what happens first? Not times 3. The squared happens first. That's the order of operations. So 1 squared is 1. And then 1 times 3 is 3. So I'm going to kind of just scratch this out down here. Hopefully there's room. You can see it. So 3 minus, all right, let's see here. I got to plug this same 1 in right here. So 6 times 1 is 6. All right. And then I've just got the plus 1 that's afterwards. So you follow what happened there? I plugged in this 1 in both spots here and here. Just evaluated each one's. Now I'm left with something that's just a star saying here's where we're at. 3 minus 6 plus 1. So 3 minus 6 is negative 3. Plus 1 is negative 2. So no calculator needed. I can put that 1, negative 2 on my graph. There's my vertex. I could answer the question now if I want what the minimum value is. Remember, this graph is going to have to open up because of what we said earlier about A. So that's the bottom. That's the basement. This graph's going to be tall and skinny, it looks like. Totally fine. The Y value is of the minimum value is negative 2. So I think we've answered everything that we needed. Boom, 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 boom. The rest is now just finishing the table and finishing our graph. So let's be smart about this, that I know this point. So whatever our x values, we'd go up to 2, we'd go up to 3, but then I'd also go down the same distance down to 0 and then down to negative 1. I don't need to replug in 0. I know that 0, 1 is a point on this graph. So also 2, 1 is a point on this graph. So we're left with one more plug-in. Let's plug in a 3 or a negative 1. You know me, I'm probably going to try to stick with the positive value here. Let's see what happens when we plug in this 3. So same as before, I'm going to just make a little note here, just kind of star and showing what I'm doing. So 3 is going in. 3 squared is 9, and then 9 times 3 is 27. So I'm going to write that down, 27 minus, let's see, 3's got to go in, so I'm taking this 3 again, and I'm plugging this 3 in now right here. So minus 6 times 3 is 18. So 27 minus 18. And then the last thing is plus 1. So 27 minus 18 is 9. And 9 plus 1 is 10. So I think that's my last set of points. That's all I need. So I guess I'll write what happened there. That equals 10. So the point 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that, all the way up to the top almost. 1, 2, 1, 2. I just kind of count it over. And I think as long as I connect them, don't forget that too. That's a little thing, but let's actually make the graph. Arrows on both ends. I think we did it. There's our graph of something in standard form. All right, one more. Again, a video notes. I understand you can skip ahead if you're feeling comfortable. You know what's going on. But why not? We're already here. I got the notes set up. Let's just go through it. So same process, maybe a little bit quicker without screwing it up. Freebies in blue. Let's go opens down. Why? Because the A value is negative. That's going to give the graph a maximum value. And just like the last one, kind of a coincidence, it's not always 0, 1, but I can look at this and see that this has a C value of 1 again. So absolutely 0, 1. Let's do the same thing. Let's put it on the graph. And let's go. So now we got to actually do some crunching. So not vertex, axis of symmetry is where we should be starting. I feel like those are flip-flop, but whatever. X equals, I'm going to try to save as much room as I can. The opposite of B, B is negative 8, so it needs to be a positive 8, over 2 times the A value, which is negative 2. So 8 over negative 4, which is negative 2. So I have an axis of symmetry of X equals negative 2, which is half my vertex, which gets my table centered. Let's put it on the graph. Here's my axis of symmetry, this vertical dashed line. We'll put the point on. Oh, I don't have the point yet. What am I talking about? Last thing we got to do is, at least as far as finding that vertex, is plugging in this negative 2. So now this is another one. I'm going to talk through it. I know I'm not showing the work, so make sure you follow if you're kind of curious. And people do struggle with this. The negative 2 gets put in here. Negative 2 squared is positive 4 times negative 2. So positive 4 times negative 2 is negative 8. So I'm just kind of jotting that first term down. Let's go to the next one. So this is really, I got to make sure I treat this like negative 8 times the same x value of negative 2. So negative 2 times negative 8 really is going to turn into plus 16. And then I've got that plus 1 hanging on the back end. All right, so I plugged in a negative 2 here, evaluated, plugged in a negative 2 here, evaluated. So this, just putting these all together now, negative 8 plus 16 is positive 8. 8 plus 1 is 9. So it looks like to me, unless I've made a mistake, which I hope I didn't, that my vertex has a value of negative 2, 9. That gets me my last kind of missing piece here as far as the maximum value being y equal to 9. We can put that on the graph, negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Some good stuff going on with that y-intercept again. So let's kind of complete our table. So we'll go up to negative 1, and then up to 0. We'll go down to negative 3, then down to negative 4. And very similar. It doesn't always work this way. It kind of depends on how far left or right your graph is going. But both of these last two examples, that 0, we were able to double up with. We were able to answer it as a freebie, and then it also served as a point on our graph. So basically, I'm 2 to the right there. I'm sorry, 2 to the right and 2 to the left of the axis of symmetry. One more plug-in. Let's get it done. We'll do kind of that same. I'll see if I can scratch it out in this last bottom spot here. Let's see. What happens when I plug in a negative 1? So if I plug in a negative 1 right here, so I'm plugging this value in right here. Negative 1 goes in, it gets squared. That makes it positive 1. But then I multiply by negative 2. That makes negative 2. All right, I'm going to have to plug in the negative 1 again right here. So negative 8 times negative 1 is positive 8. So plus 8. And then that plus 1 is just hanging out there that we'll tack on at the end. So negative 2 plus 8 is positive 6. 6 plus 1 is 7. All right, negative 1, 1, 2, 3, 4, 5, 6, 7. And then we got to be 1 to the left as well. So there we go. I think we are in great shape. As long as I finish the graph, check everything off here. Boom, 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 boom. Yep, table's filled in. We should always have 5 points in the table, whether they show up on the graph or not. And it doesn't hurt to have more. If you felt like you kind of had a real tight graph and the points were too close here, you can definitely always add more points. All right, I'm going to continue with the notes. Just know that as we did this in class, this was the spot where we broke. The lesson 2.2 day 1 would follow those notes right there. Let's keep rolling with it. Whoops, I didn't want to bring all that stuff up. The third and final form is what we call intercept form. All right, so one last time, let's roll through it here. Here's our generic form. It's going to be a similar process to everything we've done so far. Y equals A times x minus p, and then x minus q. So seeing all these letters, p's and q's, and a, b, and c, and h and k, it's all form to form. It's just kind of a way to distinguish, and they all kind of mean something different for us. So what were the things that we were looking for? Oh boy. Let's see, vertex I think we had at the top. AOS, opens, y-intercept, and max min value. All right, so same deal here. Let's start with the freebies. I'll do freebies in blue like I think I've been doing. And it's actually kind of the same ones. I'm able to tell based on that A value, if A is positive, we'll say that the graph will open up. If A is a negative value, the graph will open down. So that's been consistent with all 3 forms, basically, as far as a freebie. Just like before, if the graph opens up or down, it's going to have a max min value based on the shape of it. Don't know the vertex, don't know the axis of symmetry, don't know the y-intercept. Yikes, this form is not great for graphing. So here's where you start. This actually is like kind of an asterisk. Start by putting and this is something you should add to your notes here, start by putting x-intercepts on graph. Yikes, that's different. What do you mean the x-intercepts? We haven't talked about x-intercepts at all. They've never come up. Why haven't they come up? Because not every graph has them. Not every parabola has them. So I'll draw it here, but I'm going to erase it. The reason that we haven't talked about it because you could potentially have a graph that does this with no x-intercepts. So that's why it's not something that all parabolas have. That's why we're not focusing on x-intercepts. But I guess if we're calling this form intercept form, there's a reason for it, because I'm able to look at it and see that the points, and here we go, I'm continuing the notes now, the point P0 and Q0 are your x-intercepts. So we do get some stuff for free. Those numbers that I can see there are the x-intercepts. Now I got to be a little bit careful. Sometimes these can get complicated. 2x plus 7. What's the x-intercept? So sometimes it's helpful to think about this. I'm going to squeeze one last note in here as far as kind of like a side note. It's really more of a question. What value makes each expression equal to 0? Question. So I think it's maybe helpful to see, like, and I know it's kind of weird because we're jumping down here, even like a mini example. So let's say we had something like y equals x plus 3 and x minus 8. All right, some numbers filled in. The a value is 1. So the first thing I see on here is, okay, either one. I think this P0, Q0 is relatively easy to look at and see. Remember, they're going to be opposite because of the minuses right here. I think this question is maybe the easiest way to think about it. So treat each of these as its own expression. So what makes this expression, this x plus 3, what x value makes that equal to 0? Well, x would have to be -3, right? So -3, the answer to that question is basically, that's one of your x-intercepts. All right. This one over here, what value of x makes x minus 8 equal to 0? Well, the 0.80. So that's my other x-intercept. Where that's maybe a little bit, and so a lot of people say, oh, that's easy. It's always opposite. And that's true. X plus 3, -3. X minus 8, +8. So that is how that works. But just be aware that we're potentially going to see ones like y equals x times 2x minus 3. And now all of a sudden that question of, okay, I can't just look at this because it's not 3, it's not -2, it's not +3. What makes each of these expressions equal to 0? Well, we got to treat each one individually. What makes that expression equal to 0? 0. So one of my x-intercepts could be 0, 0, or it would be 0, 0 in this case. What makes this other expression right next to it, what makes this value equal to 0? I'm not so sure on that one. I might actually have to go, set up an equation. I know I'm really tight on space here, but I might actually have to calculate, okay, what x value makes that equal to 0? Oh, okay, I'd add 3 to both sides and divide by 2. X equals 3 over 2. So my other x-intercept is the point. Can I squeeze it in here? 3 over 2, 0. Okay, so I know it's a real side note and there's all this stuff going on here. We didn't do this with the other forms, but I wanted to, it's different. I mean, obviously it's a different form. It's an intercept form, but there are some easy ones like this one here, like, oh, sweet, -3 and 8, done, easy, quick, x-intercepts. But there's potentially ones that are maybe a little bit trickier. All right, and we'll try to, I know in the word problems we'll see some like this, but just wanted to get that out there so we were aware of it. Okay. All right, so I still haven't answered vertex, axis symmetry, y-intercept, maximum, minimum value, but that's where you start. Start by putting those on the graph. All right. The next thing we are going to find is the axis of symmetry. There's 2 ways to find it. Okay. The fancy kind of formal way is to take those P and Q values, add them together and divide by 2. Average them. So for our little mini example here, I would go 8 plus -3, which is 5, and divide it by 2 and get 2.5. Our axis of symmetry here would be x equals 2.5. And I'll do it this way. There's kind of an alternate way to think about it. Instead of doing the P plus Q divided by 2, it's just one more formula that some people are like, I don't want to memorize that. You might just think about, and we'll do it, so maybe this will make more sense once we do it on an actual graph, is count to middle. All right. And again, maybe that right now doesn't make a ton of sense, but I'll show you what that means when we do one of the examples. Okay. From there, at least, and that's a different setup. That's a different start. I totally get it. We'll have to do it and practice it. Once I get that, most of this is very similar to the standard form, where my vertex is going to be our AOS value. Okay, so whatever we just figured out right here to start, axis of symmetry, just like before in standard form, I'm going to plug it in, or I'm sorry, that's half of my vertex. That's my x-coordinate of my vertex. And then we're going to use plug, let's use that same terminology, plug AOS value into function. I think that's pretty much how we worded it before. That's how we're going to get that y value of the vertex, which then in turn ends up being the y, that's our maximum minimum value, same as before, y coordinate of vertex. And then kind of like our first form, vertex form, there's not really an easy way to identify it, so we're just going to have to plug in 0 for x and see what we get for y for our y-intercept. So a little bit different here. I know this looks really, really cluttered, so hopefully you were able to follow kind of as we were doing it. Maybe you had more room. Hopefully you did as you added those to your notes. All right, let's do one, and I think hopefully that'll clarify any things that we were maybe had questions on. All right. All right, so here we go. Let's do our freebies like we've been doing. I can look at this and see a negative a value, so I know this is going to open down, which is going to take on that shape, which is going to give us a maximum value. All right, beyond that, I think I'm out of luck. So what's the first thing we said to do? We wrote it. Maybe I'll reference this one a little bit more, kind of way at the top here where I said start by putting the x-intercepts on the graph, thinking about what makes each of these 0. So what makes this expression equal to 0? 1. So I'm going to write them down here. The point 1, 0 is one of my x-intercepts, and I'm going to plot it. What makes this expression equal to 0? Well, 5. So that means the point 5, 0 is my other x-intercept. Let's count it out. 1, 2, 3, 4, 5. Great. And you're kind of like, well, what the heck? I still haven't filled any of this stuff in yet. I don't know the vertex, don't know the axis of symmetry. That's where we started. Put those on the graph. Hey, we got 2 points. All we need really is 3 more. I need the vertex. I know it's going to open down. It's going to be up here somewhere. And then we'll find something in between them. All right. Axis of symmetry. So here's what I mean. There's the 2 different ways to calculate it would be do the 5 plus 1. So if I want to use the formula, I'd go 5 plus 1 divided by 2. So 5 plus 1 is 6. 6 divided by 2 is 3. So absolutely, my axis of symmetry is x equals 3. What a lot of people like to do, and I'm kind of in that camp too, is just count towards the middle. So if I move over 1, 2 from the right, and I move over 1, 2 from the left, it puts me at this spot right here. So without actually having to add and divide or anything like that, I can see that, hey, this green dashed line is right in the middle of those 2 red points. What's the equation of this line? Let's see, 1, 2, 3. Oh, x equals 3, which I know we already wrote down, but that's a kind of an alternate way to get there. You don't necessarily have to do the calculation. Sometimes people get so hung up on P plus Q. What's P? What's Q? Count to the middle. Find the average, find the middle by counting. All right. Like before, that gets us rolling here a little bit. All right, vertex. I know half of the vertex. It's 3 something. That gets my table centered. 3 something. The last part, and for basically the rest of this now, is kind of like we saw with standard. All comes down to us being able to plug points into this function. Okay, so let's do it. Let's plug in this 3 value in all these spots. So I'm going to do that same kind of notation where I just kind of star and say, all right, here's my work. I got this -2 times right here. Remember, that's multiplication right there. So -2 times, there's not really anything to do, but let's plug in. All right, 3 up here. 3 minus 1 is 2. All right. And then there's another times right here. So let's go another plug-in of 3. 3 minus 5 is -2. So in the end, the calculation to get our y coordinate of our vertex is -2 times +2 times -2, which is +8. 2 times 2 times 2. There's both negatives, so they cancel out. +8. So there we go. 8. The max value is y equals 8. Look at that. I wrote 8 3 different times. Answered, got me going. So let's see here. Let's plot that point. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Now, let's work smart, not hard, that I know these points in here. So why don't we go maybe up to 5? And then 2 and 1 and say, hey, 5, 0, 1, 0. You could work super smart and super efficient and say, you know what? I'm going to go one more to the outside here and just go to 6 and 0. Because what did we say? That the y-intercept is always going to be 0 something. So I'll probably just end up plugging it in as part of like an extra point. But you could be really efficient and say, hey, I know my vertex. I know 5, 0, and 1, 0. I'm just going to branch out from there and get my last part. So I'll just end up doing 2 plugins here. So, all right, here we go again. The next value that I'm plugging in to make my graph is 4. I'm plugging that in for x, because that was the next x value up. So I've still got the same old -2 that's out front there. That's going to be multiplied by, all right, let's go 4 minus 1, which is 3. And that's going to be multiplied by, because there's a multiplication right here, let's go 4 minus 5, which is -1. So when I crunch those numbers, 3 times 2 is 6. There's 2 negatives. They should be positive, so I end up with a +6. Cool. 1, 2, 1, 2, 3, 4, 5, 6. Now, graph-wise, I think I'm done, but because there's the room and I'm pretty sure that this is going to end up hitting down here somewhere, let's be accurate and do it the right way. So I'm going to plug in this 0 for both x's and do one last number crunch. Oops, meant to switch over to black there. All right, one last time with the -2 hanging out front times, I'm plugging in, whoops, I didn't mean to do this. I have this meant to be a 6, so sorry for the confusion. 6 right there. I'm plugging in a 6. All right, so 6 goes in. 6 minus 1 is 5. And then 6 is going in right here. 6 minus 5 is 1. So times 1. Now we are negative. So 5 times 2 is negative. 5 times -2 is -10. So -10. I don't necessarily have to fill them in here. Really, the big part was right there. So now I know that the y-intercept is -10. It does fit, so I am going to plot it. Like I said, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And over to there. So there we go. Let's finish this up the right way. Hopefully my smartboard's not skipping too much on me here. I kind of missed that last point, but it's close enough. I think we did a good job. I think we got everything where it was supposed to go. We answered all the questions. Yeah, we're in pretty good shape. All right. Last one, kind of the on your own. Let's do it. I'll do it. You can feel free to skip ahead if you're feeling comfortable. But obviously, the flip would be if you're struggling, you probably want to check this one out. So we'll go quicker. All right. Opens, freebies, right? Freebies in blue. Opens up because the 1/4 is positive. That gives us a minimum value right there. That's all I get for free. All right, so the next thing Mr. Kroll said to do was put those x-intercepts on the graph. I see 1, 2, 3, 4, 5, 6, 0 as one of my x-intercepts, and I see 2, 0 as my other x-intercept, right? We're thinking about what's going to make each of these expressions equal to 0. So 6 and 2, all right, cool. The next thing I would do is count towards the middle, 1, 2, 1, 2. So I think this line, this vertical line, we'll do it in green. I think that's how I did it last time. Ends up being my axis of symmetry right down the middle. All right, so I count that off and say, all right, that is 1, 2, 3, 4. X equals 4 for my axis of symmetry. Awesome, we're getting there, we're plugging away. Vertex, that's half my vertex, 4 something. 4 goes in the middle of my table. It's all at this point kind of plugging it in. So let's do it. Not blue, that's our freebie. Let's go here. So if I plug in this 4, I'm going to go 1/4 times 4 minus 6 is -2 times 4 minus 2 is 2. So I'll work with these, I guess, first. 2 times -2 is -4, and then I divide it by 4, I get -1. Not terrible. I know that 1/4 is kind of scary, but 4, -1. So it looks like we're going to get a flatter graph for sure. Now here's kind of the beauty, that if I go up to 5 and 6 and down to 3 and 2, I've got a couple of these done already. So let's say, what do we say, 6, 0 and 2, 0. Let's not get too far ahead of myself. I guess I should fill in some of the stuff. -1. My y value minimum is y equals -1. All right. So last couple plugins here for us. We'll do in purple. We've got, yeah, why not? I already wrote down the 5. Probably not necessarily going to be a great number, and that's okay. With the 1/4, we said that's potentially going to happen. So 1/4 times, let's see if I plug in a 5. 5 minus 6 is -1. And if I plug in a 5 and the 2, I get, or I'm sorry, 5 minus 2 is 3. So -3 times 1/4 is -3/4. Not a beautiful point, but a point on our graph nonetheless. So let's plot it. 5, just slightly kind of above there. I probably would want to go one more point just to get this is kind of what I talked about before, that we want to be accurate with our shape, and those are so tightly packed together that it's probably in our best interest to get one more. And I need one more anyways, right? I need a y-intercept. So why not just find the y-intercept, because we have to anyways, and use that to kind of clean up our graph. Works out pretty good, I think, okay? So I'm going to do one more. I'm going to plug in a 0 for x and see what happens. So here's my last set of plug-in points. 1/4 times, let's see, 0 minus 6 is -6 times 0 minus 2 is -2. Hey, look at that. It's actually going to turn out to be a decent number. -6 times -2 is +12, and then 12 divided by 4 equals 3. So look at that. Decent. And if you don't want to put it in the table, that's fine. 0, 1, 2, 3 is right here. Just count back to your axis of symmetry. So I'm counting back 1. I know you can't see it. I'm counting with my pen, though. 1, 2, 3, 4. 1, 2, 3, 4. Remember, they always kind of come with a partner, so it's equally spaced out there. There we go. That's a decent graph. I like that. Kind of a flatter deal as far as we've seen some tall, skinny ones. This one's a little bit stretched more horizontally, or stretched or shrunk vertically would be another way to say that. All right, we survived. We made it. We made it through the graph part. All that. Holy cow! This is by far the longest notes video. You can see why we split it up over the course of a couple days in class. All right. So the last thing we've got to do, we can graph quadratic functions in vertex, standard, intercept forms, identify key features. That's all just part of the graphing process. Check. That's not a good check mark. Check. I'm using my mouse there. The last thing we got to do is, all right, solve real world problems. Everybody's favorite. Oh no, we can do it. Come on, stay with me here. You can see there's a couple different looks that we'll go through here. Maybe we'll skip the last one. We'll see. I guess if I'm doing the video, I might as well just do it. All right, here we go. The trick, there's not really any new notes, like as far as like, oh, here's a trick on how to do this. I guess the one piece of advice I would give you is the word problems are no different than the graphs. They usually end up, or if when in doubt, maybe that's where we can just kind of be like our generic note. When in doubt, on any one of these word problems with involving a parabola, let's say ID, so like for identify key features of graph. And that was the phrase I used in class, was Word problems are graphs in disguise, or not even in disguise. There's literally a graph here. When I say key features, what am I talking about? Those key features that we answered for every single graph. What is the vertex? What is the axis of symmetry? Does the graph open up or down? Maybe the y-intercept. A lot of times we're looking at the maximum minimum value. Okay, without actually going through the whole fancy formal process of plotting points and making a graph, but you're actually going to end up answering this part, like go through this process for each word problem. Okay, so when in doubt, that's kind of the game plan. Let's read what's going on here. I know it's small, but obviously if you're watching at home, you're probably watching on your Chromebook. You should be able to see it. So the parabola on the left here shows the path of your first golf shot. So we're out golfing. I hit the golf shot. Sure, it took on a shape just like that, where X is the horizontal distance in yards, and then Y is the height in yards. So we're working in yards today. The path of our second shot can be modeled by this function. Decimal, negative number, not so nice looking. Which shot travels farther before hitting the ground? Which shot travels higher? So let's break this first graph down, just kind of tying some of these numbers to like the horizontal distance and vertical distance. So vertex. So the first thing I see right here that jumps out at me is the vertex of this parabola is the point 50, 25. So for my first shot, that tells me that what is the y coordinate of our vertex? It's always the maximum or minimum value. So the maximum height of our golf ball was 25 yards. All right, so that's where we kind of start to interpret. We use that exact same terminology on all 6 of our graphs. What was the maximum or minimum value? This graph could be a golf shot, a really high arching golf shot that had a maximum value of 8, 8 whatever units, but it's that same idea. The x-intercepts, I know that's not necessarily one of our always key features, but I see this one that's saying, hey, there's an x-intercept here and right here. I can tell just by looking at this that horizontally this ball has traveled 100 yards. So let's say it like this. The horizontal, and I'm going to abbreviate, distance is 100 yards. So the first one was awesome. Like, hey, that's sweet. We were able to tell the max height. I was able to tell the horizontal distance. Started at 0, 0, all the way to 100, 0. Right? The height of 0 means it's on the ground. So the y coordinate of 0 means it's on the ground. It's on the ground. The second shot's not so nice, right? So second shot, we've got this model right here. And I'm just going to switch it over to y equals negative 0.02x times x minus 80. Saying, oh, why couldn't they just give us another graph for that one? Well, that's what I'm asking you to do. Essentially, let's make a really informal graph that kind of looks like the first one, but we're gonna have to calculate some of those values. So I see this here. The first thing we should be doing is identifying the form. What form is this in? Is this standard form? Is this vertex form? Is this intercept form? So let's look. I mean, I'm not going to do this for every single one, but all right, vertex form. It's got a squared in it. There's an H and a K. I don't have that going on here. Is it standard form? AX squared plus BX plus C. Nah, I don't think it's that one. I think it's more this one where it's some parentheses. I don't see a squared going on with this one, or to a second power. So I think we're in that one, although it does look a little bit different, right? This out here. So this is more now where we got to kind of think about, okay, this is intercept form. All right, intercept form. What did Mr. Kroll say to start? How do we start intercept form? Obviously, the negative number in front tells us that this graph is going to open down. So I'm starting with, hey, the shape of the graph is going to open down. And of course, hopefully we assume that it's going to be very similar looking to the first graph, right? It's going to open down. But that negative is not lying to us. This negative 0.02 is telling us the graph's going to open down. All right. What's the next thing? What was that asterisk we wrote there? Start by putting the x-intercepts on the graph. Okay, we can do that. What are my x-intercepts? What's going to make each of these expressions equal to 0? Oh, wait a minute. 80, right? If this is 80, that means one of my x-intercepts is 80, 0. What's going to make this expression right here equal to 0? So kind of ignoring the x minus 80 and just focusing on negative 0.02 times x, what does x value have to be to make that 0? And of course, the answer is 0. So my two x-intercepts are 80, 0 and 0, 0. They're clean numbers. I know it's a negative 0.02, and that scares people off, but that means that this point 80, 0 must be over here, and 0, 0 must be over here. All right, so that definitely is starting to look like this first graph. What's the next thing we wrote down as far as like the game plan? Start by putting the x-intercepts on the graph, count to the middle or average your P and your Q values. So for us, I don't think we have to be super fancy. What's halfway in between an x value of 0 and an x value of 80? I think everybody's probably screaming 40. So now we know that our axis of symmetry is 40. What did that always mean? All right, I wrote it every time. We had a 4. That was the x-coordinate of our vertex. So that we win on a couple different levels. Hey, my axis of symmetry, let's write it off to the side. AOS, x equals 40. But that's also half my vertex, the point 40 something. And that something's kind of the last big number that we're looking for. I think at this point, I could answer some of these questions, like which shot actually travels farther before hitting the ground. We'll come back to it because, like I said, I think we could do it now. But let's just finish up. We're right kind of in the middle of a calculation here. The last thing we got to do, let's find this y-coordinate of our vertex. So that's going to involve plugging in this 40 into the original function. So y equals negative 0.02 times 40 times 40, the quantity 40 minus 80. So there's maybe a little bit of simplifying that I might do before I type that into my calculator. I am going to use my calculator. This is definitely one, and most of the word problems probably do involve using the calculator. Although it's not terrible. 40 times negative 40 is negative 1,600. And then the last thing we got to do is multiply times negative 0.02. When I crunch that number, and I'm just reading it right off my calculator, I'm doing it with you, I got 32. And I think that's reasonable. It's not like 5 million or some crazy decimal. So I think the y-coordinate of my vertex is 32. The point 40, 32. I'm going to write that kind of off to the side here as my vertex. And I think we could stop. I don't need to find the y, although we do know the y-intercept, but you can kind of start to look. This is really like answering all those questions we did. We found the axis of symmetry. We found the vertex. We actually know the y-intercept. We know it's going to open down at a max. The only thing we didn't actually go through was plot points and make the graph. So that's what I mean when I say it's kind of a graph in disguise. So they're not ones that we can just really look at and say, oh, there's the answer. There's the answer. We actually kind of have to go through this process. So to kind of finish it now, let's tie it all. Let's put a little bow on it. Which shot traveled farther? I'm going to see if I can squeeze it in here. Farther, question, and higher. I'm just going to abbreviate just because I'm really tight on space. The farthest shot was the first shot. This one traveled 100 yards, while my second shot traveled 80 yards. So first shot traveled farther. The higher shot was right here. Which one had the greater max value? All right, 25 versus 32. Clearly the second shot traveled higher. All right. So that's how we're at least going to approach that type of word problem. I mean, you're going to try to make a little informal picture, treat it like it was a graph, identify those key features. For this one, we did x-intercepts because that was the form, axis of symmetry, vertex. The on your own one here is a follow-up, so we may as well go through at least this on your own 4, because I think it's a third golf shot. So the graph of your third shot is another parabola through the origin. So that's kind of a nice piece of info through the origin that reaches a maximum height of 28 yards when x equals 45. Holy cow. I see that, and I get a picture right away in my head of if we traveled from the origin, right? The origin is 0, 0. That's an old school term that you learned about when you first started plotting points. Probably going to take on that same shape that we had not too long ago. And it tells us that it reaches a maximum height of 28 yards. Whoops. Maybe I'll write it below here because I know I'm writing up into the words. That this point has, after we've traveled, when x is 45, basically my axis of symmetry would be 45. So the point 45, 28, it's indirectly telling us that that's your vertex. Right? It reached a maximum height of 28 when x was 45. So we traveled right 45, went up 28. There's our vertex. Cool. That's huge. Like, that's a big piece of information. Compare the distance it travels before it hits the ground. Wait a minute here. Hold on. We don't know this over here. Oh, man. Or do we? Sure we do. We can actually, it's not that bad, because if this axis of symmetry is always right in the middle of those x-intercepts, and that was one of those features of an intercept graph, that the axis of symmetry is always kind of count right towards the middle. Remember, we counted a few times towards the middle. Okay, then that means that if I went 45 right, I got to go another 45 right to get to here. So this is the point 90, 0. So I think it's in between, actually, right? Our third shot, it says compare the distance it travels before it hits the ground with the distance of the first two. What was it? It was 80 and 100, right? So our first shot traveled the farthest. Our third shot traveled 90 yards. And our second shot ended up traveling the shortest, 80 yards. All right, so just a different look. The way the information was presented was slightly different. It gave us the max height. Didn't give us this x-intercept over here, but we were able to figure it out. All right, let's look at one more form, okay? Because basically a word problem could be presented in any form. We're seeing right here, oh, I know this one's going to be an issue for space. In class, we must have did it on the whiteboard. So here we go. But right off the bat, I'm looking at something here. I'm seeing, that's not intercept form. That's standard form, right? ax squared plus bx plus c. So now if I'm stuck, I'm going to go back and reference those notes on standard form. All right, we've got a couple of freebies. Going to open up y-intercept. That's worth knowing. Okay, the y-intercept, cool, some freebies. Where would we start a standard graph? That's why I put the star here, because we want to start with the opposite of b over 2a. So that's right off the bat. I'm just saying, hey, it's standard. Let's look at the standard notes and kind of go through that process of what we did on those graphs. Okay, I'm probably gonna have to scroll a little bit. I don't like doing that on the video notes, but it's just kind of the way we're gonna have to do it. So let's read the situation. X is horizontal distance in feet, Y is vertical distance in feet. So the path of a basketball thrown at an angle of 45 degrees can be modeled by this right here. Okay, not pretty. There's a negative 0.02. That's kind of coincidental, but for part A, it's asking us, what is the maximum? We've seen that word like 6, 8 maybe times today. The maximum height of the basketball. That's very indirectly saying, find the y-coordinate of the vertex. That's always been true for every parabola. The maximum minimum height is always the y-coordinate of the vertex. Okay, let's do it. And I was kind of already hinting at it. Here we go. Let's see if we can do this. Get some space here to kind of work. Whoops, didn't mean to do that. Falling apart here at the end of the video. Stay with me. All right, so kind of want to just tap this here. All right, here we go. What's the maximum height? So I do kind of want to do just a relatively like that's kind of crummy. Let's start over there. I do want to make somewhat of a picture here. Now, what's going on here? Why am I making this one different? Like, Mr. Kroll, you're killing me. Because I know the y-intercept, right? That was one of the pros of this form. That was one of like the freebie things that we knew, that this graph must start at the point 0, 6. So that's why I decided to make my graph that way. So that's one of the freebies that you get. Remember, that's your y-intercept. So if I'm making a graph, I might as well make it at least semi like believable. Okay, what's the maximum height? We still don't know. How do we go about doing this? Opposite of b over 2a, right? That's start with the axis of symmetry. Opposite of b, so b is right here, it's 1, so the opposite of that is negative 1, and then all over 2 times a, which is negative 0.02. So that's kind of a clunky plug-in on your calculator. Make sure you're able to do that. Maybe just do the 2 times negative 0.02 first in the denominator and just get it down to negative 1 over negative 0.04, and then do that division. 1 divided by 0.04, 25. So remember, that's your axis of symmetry. That means that we've traveled 25, I think we were talking feet again. The vertex coordinate is the point 25 something. Our work here, or the majority of the work we have left, is figuring out what is that y coordinate, because hopefully by now we're associating that with the maximum or minimum value. So last thing I think, at least for part A here, that we have to answer is, or that we have to do, is plug in 25 for my x value. So I'm just going to write it out so I can see it. Negative 0.02 times 25 squared plus 25 plus 6. So give me a second here. I got to crunch all those out. 25 squared times negative 0.02 plus 25 plus 6. I got a value of 18.5, which sounds reasonable. So by itself, it's just some random 25, 18.5, but that's huge for us. That's our vertex. There's our axis of symmetry. There's our y-intercept. The graph's opening down because of this right here. That's our maximum minimum value. So we've essentially answered every single one of those 5 features. What is the maximum height of the basketball? No doubt, 18.5 feet. So I'm just going to kind of circle it in here. Max height, let's just put it right here, 18.5. And let's throw our units on there, feet. That's the max height. A little bit of a different question for part B. If we can scroll down, I think we should be fine here. What is the height from which the basketball was originally thrown? And I think I kind of answered that already, right? By just kind of recognizing that, hey, my y-intercept, I kind of took that into account when I made the graph, that this person must have, be 6 feet tall, and they're throwing it from above their head, or they're making a chest pass. They're really tall and they're making a chest pass or something. But that the ball was, before it traveled any horizontal distance, was starting at 6 feet up, because of that being our y-intercept. So no calculation needed. What is the height from which the basketball is initially thrown? That's a key word for us there. We can just say 6 feet. Cool. I know the last one is a very similar one, but I've said it 3 or 4 times already. I may as well finish the notes here. So definitely, if you're looking for word problem help, or you're kind of like, I could still use a little more practice, definitely let's go through it. Let's watch this. Otherwise, feel free to kind of move along. Last one, very similar, right? We're launching a shot put. All right, it's launched. I can tell already off the bat. Maybe we want to just answer this right away. What is the height from which the shot put is initially thrown? 5.5 feet. Let's go through it, though. I'm going to follow that same process of, I'm going to make a really informal graph. It's launched from 5.5. It goes up. It hits the ground. We're throwing a shot put. So that's the 5.5. That point right there, not very good point, but it is what it is. Here's our vertex. Maybe it's just, maybe you're here and you just want to get some calculator practice. Like, how am I going to figure out what's that maximum height there? So just by looking at it, I have no clue. I got to go through that process of opposite of b. So opposite of 0.7 is negative 0.7 over 2 times negative 0.01. So do that calculation, 2 times negative 0.01. I'm getting, as a denominator, negative 0.02, negative 0.7 up top. And I'm getting an x value of 35. So our axis of symmetry is 35 feet here. 35 something is my vertex. Let's plug that 35 in here. and finish this one up. Negative 0.01 times 35 squared plus 0.7 times 35 plus 5.5. Holy cow. Let's do it. 35 squared times negative 0.01 plus 0.7 times 35. I don't have this written out. I'm doing it right with you. So plus 5.5. So I'm getting 17.75, which again seems reasonable. Believe it or not, I used to throw the old shot put, so it seems like that's a decent, a relatively believable height there, 17.5. All right, so what is the maximum height of the shot put? I think we've answered that question. It travels about, let's just write it right up here, about, or exactly, I guess, 17.75 feet. All right, and then the last one, what is the height from which the shot put is initially thrown? It's very similar to the basketball one. This one was launched from a height of 5.5 feet. Whew, that is a doozy. Holy cow. But I think we got through it. I think we did it right. It's good reference for anything, whether you're struggling or whether you're just seeing it for the first time. Go back through, rewatch anything. That was the notes that we did in class. Even some extra examples we didn't get through every single one of those in class. So did we hit them all? I think we did. Finally, we can check off that last one. We didn't look at a vertex form one. So the word problems do vary. We looked at two types, a standard form and an intercept form. But even within that, there could be lots of variation and stuff. So make sure we're getting the practice where we need to. But I think as far as the notes goes, that is what we got. So I am going to call it there. That is lesson 2.2 notes in the books. I will see you in future lessons.